this video will cover notes on simplifying radicals. First of all, before we get into simplifying radicals, we need to define a couple of things. First of all, the product, so that is multiplying, of two identical factors. So if you're multiplying the same thing by itself, this is called a square. We've done this before, so like 2 times 2 is 4, 3 times 3 is 9. So 2 squared is 4, 3 squared is 9, so that's called a square. Finding a factor used to obtain a square, so that is what would be, if I were to have 9, then what times itself would make 9? Then what that's called is called taking or finding its square root. So if I wanted to find the square root of 9, then the answer would be 3. And it's represented by this symbol here, which is actually called a radical. And when we're finding two identical factors, it's called a square root. So the perfect squares, you need to memorize this list. Okay, you should already have most of them memorized. We've done this before. But again, perfect squares, and that's important here for our perfect squares. 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and then 225. Okay, most of you should have through 12 already memorized, 13 through 15. I also want you to memorize those as well. So it's your job to make sure you have this list memorized. So then if I were to ask you for the square root of any of these perfect squares, so if I were to ask for the square root of 64, you need to be able to tell me that that's 8. All right, so let's look at a couple of examples. So again, this is pretty easy. Evaluate each expression. If you have a perfect square underneath this radical, then it's very easy. The square root of 49 is 7. Then, sometimes you might have a negative in front for b, and that would be the negative square root of 144. Well, the square root of 144 is 12, and then you multiply by a negative, so that's negative 12. But then sometimes you have the case where the negative is inside with 25. Now, remember the square root is the product of two identical numbers. There's no way that two numbers could multiply to get 25. So if you have a negative inside a square root, that is actually not possible. So that would be no solution. All right? Now, a couple of properties with square roots. Square roots and squaring something are inverses of each other. They undo each other. So if you have the square root of 5, and then that's being squared, that means the square root of 5 times the square root of 5. And actually, there's a property that says if you multiply those, you can multiply 5 times 5 together, and that becomes the square root of 25, which then you get back out 5. So you can actually skip those two steps because the square root and the squared cancel each other out. So if you have the square root of 5, and then that's being squared, you're just going to end up with 5. Now, the same thing applies for b. You have 15 squared, and then the square root of that. So again, if you looked at all of this written out, 15 squared is 225, and then we take the square root of that, so that's just equal to 15. So again, you can skip this step because that square root and that squared cancel each other out, just leaving you with 15. Now, part C is a little bit different because you have this negative. Now notice that the negative is in parentheses and then squared. This is actually not no solution like the one above it, because if you were to square negative 13 times negative 13 is actually going to end up being a positive 169, and then the square root of 169 is 13. So as long as you have those parentheses here, then the square root of negative 13, or after it's squared, will end up being back at 13. Okay, not negative 13. All right, and then, so looking at in A, we were able to say, looking here really quickly, square root of 5 times square root of 5 is the square root of 25. It's okay if I'm multiplying radicals to multiply what's inside. That 5 times 5 is 25. However, let's see if the same thing holds true with addition. So what we're going to do in part A, we have 3 squared plus 4 squared. I'm going to work this out and see what I get. So 3 squared is 9, plus 4 squared is 16. Then 9 plus 16 is 25, and the square root of 25 is 5. So what we want to see is if I add 3 squared plus 4 squared, is that the same as if I take that apart and say that that's 3 squared, square root of 3 squared, plus square root of 4 squared. So I'm going to do this. The square root of 3 squared, we already know, we don't even have to do the square root. Those are going to cancel, leaving you with 3. Then plus the square root of 4 squared is 4. I get 7. Notice that I do not get the same thing as I did over here. I got 5. So therefore, if you have an addition, then you cannot split those up. So that is not the same as if I split that up. That's important. Okay, so multiplication you can do that, but addition you cannot do that.